A jet plane carrying 3,000 kilograms of ethane burns off all the gas, forming water and carbon dioxide. If all the carbon dioxide is expelled and all the water formed is condensed and kept on board the plane, then the gain in weight is dash. Solution. Before we proceed, if you are yet to subscribe to this channel, kindly do that and click on the notification bell as well so as to be notified as soon as new videos have been released. There is a link in the description box to our Telegram channel, which is also displayed on the screen right now. You can join our channel via the link for better communication. Going back to the question, we have ethane, which was born to form water and carbon dioxide, and are being asked to determine the gain in weight if the water formed is condensed and being kept on board while the carbon dioxide is being expelled. So the first attempt to this question is to write a chemical equation showing the combustion of ethane. So when ethane burns, that means ethane is reacting with oxygen. For ethane, we have C2H6 reacting with oxygen, O2, to give water and carbon dioxide. So after writing the equation, the next thing to do is to check if it is balanced. Looking at this is not a balanced chemical equation. So let's go ahead to balance the equation. Here we have two atoms of carbon present, and in the previous side we have just one. So if we add 2 here, this makes carbon to be balanced. Then for hydrogen we have 6 and 2 in the previous side, so let's add 3. Hydrogen is balanced, oxygen is 2. But in the previous side we have 3 plus 2 times 2, that's 4. We have 7. So here we are to balance oxygen, that will be 7 over 2 to make it 7. So if we have 7 over 2 here, we can say it is balanced, but then we do not want a fraction, we want a whole number. So let's multiply all through by 2. So then we now have 2 moles here. There are 7 moles of oxygen to give 3 times, so that's 6 plus 2 times 2, 4. So now we have a balanced chemical equation. So the next thing to do now is to determine the reacting mass of the reactant and the mass of the product we are working with based on this question, and that is ethane and water. So to start with ethane, the molar mass of ethane we determine the atomic masses of each of the elements. For carbon we have 2 atoms, so 2 multiplied by the atomic mass of carbon is 12, plus for hydrogen that will be 6 times 1, the atomic mass of hydrogen. So this gives 24 plus 6, which is equal to 30 grams per mole. And based on the equation above, the reacting mass will be the number of moles times the molar mass, just as the formula for mass. So the number of moles will be gotten from the equation, and here we have 2 as the coefficient, and that will be serving as the number of moles. So say 2 moles multiplied by 30 grams per mole, this gives 60. So this is 60 grams. Then for water now, let's calculate molar mass of water. We have 2 atoms of hydrogen, that's 2 times 1, the atomic mass, plus atomic mass of oxygen 16. So this gives 2 plus 16, which is equivalent to 18 grams per mole. So mass of H2O will be equal to The number of moles according to the equation will be 6 moles multiplied by 18 grams per mole. 6 times 18, we have 108 unit grams. So we've calculated the reacting mass of ethane according to the equation, and we've determined the mass of water that will be liberated based on this balanced chemical equation. So now going back to the question we are given, we are made to understand that 3,000 kilograms of ethane burns. So if 3,000 kilograms of ethane burns, what mass of water will be liberated? To get the mass of water that will be liberated, we'll be using the relationship according to the equation that 60 grams of ethane C2H6 will produce 108 grams of water. When 3,000 kilograms of ethane burns, it will yield S kilograms of water. So X will be equal to, cross multiplying this, we have 3,000 kilograms multiplied by 108 grams divided by 16 grams. So this gives, multiplying the numerator, we have 324,000 divided by 60 units in kilogram, which is equal to 5,400 kilograms. At least 5,400 kilograms of water will be produced. This could have been the final answer, but then we won't stop here. Why? This is because according to the question, we are asked to calculate the gain in weight. Now, from the calculation we just did now, we've determined the amount of water that will be formed. So if the water is being kept and the ethane has been burnt off completely, carbon dioxide has been expelled off. So that means it's only water that will be left. So now the weight gain will now be the difference in the initial weight of ethane that was burnt and the water that was being condensed and kept in the plane. We'll be subtracting the mass of ethane that was burnt from the mass of water that was being condensed. So let's do that, then we'll come to the end of the solution to the question. So here we say gain in weight equals weight of H2O minus weight of ethane. Which equals the weight of water, that's 5,400 kilograms, minus weight of ethane, which is 3,000 kilograms, and this will give a total of 2,400, and this will serve as the final answer. That will be all. Do not forget to subscribe this channel and also click on the notification bell so as to be notified as soon as new videos have been released. There is a link to our Telegram channel in the description box. You can join our channel via the link for better communication, and also don't forget to leave your comments in the comment section below. Thank you.